accepted.
See, this is what happens when you don't test your stuff before going to production, right? So let's check the microphone. Microphone check, check, 1, 2, 1, 2. Let me check the other one, if it also works. 1, 2, 1. Okay, this one also works, perfect. So back to the main one. Okay, let's do the audience check. Audience check. Raise your hand if you're in the room. Okay, so I guess people who didn't raise their hand, they're not in the room, they're still somewhere. Maybe they're digesting their lunch or coffee or whatnot, I don't know. How's the conference? Do you like it? Does it feel good to be back? Yes, I see people nodding. Yes, it feels good to be back, absolutely. Please welcome to the session called, or entitled, Integration Tests Are Needed and Simple. I had to read it myself, not to confuse it. Yes, let's hit it. So briefly about me, I'm Piotr Przybył. You can find me in various social media here. I'm software gardener. I'm also a trainer from time to time. And I post some stuff sometimes on my personal blog page called softwaregarden.dev. The question is, question. I've been doing Java for quite a long time, right? Like since 1.3 and also other languages along the way. I've seen my share of like production issues and whatnot. So the question is, who are you? Who in this room is a Java developer? Very nice. Who's not Java developer? Okay, folks, but are you like, let's say JVM or /JDK people? Or do we have in the room anyone not doing Java or not being able to pass the... Okay, we have people who are not doing like anything. Okay, so what do you do? Shout. Rust, right? Okay, Rust. Good, we'll come to that. We'll come to that. Okay, conference. We are at a lovely conference. And conference, especially if it's a multi-day conference like Devoxx Poland, it involves some parties, right? And parties involve certain beverages and other joys of our lives, right? Especially that we can finally reunion after the pesky pandemic, right? But still we have someone who we love at home, right? Let it be your granny, it can be your mummy, it can be the auntie or a sister or your grandpa, someone like this, someone you love, right? And it's been a long, tough day, right? Because you've been to this conference. There are so many great sessions, and you wanted to attend really all of them. And they started in the morning, well, maybe not early, but in the morning, and after the whole day, and meeting all these people, and people are exhausting, right? But then in the evening, you receive a call from your granny, mommy, or an auntie, and they say, look, my sweetheart, I'm afraid this COVID impacted me more than I thought. It seems that it really impacted my smelling. I can't really smell things as good as I was able to do that before. Right? So maybe you can come to my apartment, to my kitchen, because I have this old gas stove, and I'm not sure if it's not leaking gas. Right? Because like a neighbor told me they can smell some gas or something. So maybe you can come and install a device, right? And then what can we do as a software developer or software engineer or a software artist, right? We can do the following thing. I'll be running a little experiment, hence let me play it by the book, like a health and safety protocol, right? Because it's going to be like a real demo. And you know how it works with demos. Sometimes they don't work, right? So keep your fingers crossed that it works. So what do you do as a software person? Let's put it that way. We have two options. We can look for a software that's already doing the thing, right? Or like a hardware that's already doing the thing. Or we can build it our own. And building something our own has this advantage that not only it can get more expensive, but at least we can deliver it after a deadline, right? That's a very good property of things we build ourselves. So, of course, we, as a seasoned software developer, we're going to go for that approach first, right? We're going to build a smoke detector our own, right? And so how do we build a smoke detector? Right, we need some kind of a casing. So let's say this is a nice case, right? It should do. Sorry, it's some kind of like green filter or whatnot. Sorry, I don't know. Still, you should be able to see what I'm doing. So first, what we need is the actual smoke detector. Let's call it the sniffer, right? Thing that can detect if there are gas particles or not. So I got this thingy. See, it clicks. Makes very nice sounds of clicking. And I'm not going to test it. I mean, I bought it from a certified vendor, and people on sourceforge.net said it's really good and reliable, and it's being used by many people for like 15 years, so let's just add it to our box. Then, of course, this whole thing needs some power, right? So I happen to have this power source, with solar batteries, and I need to test if it's providing some power, like this thing, right? So how do I test it? And to test it, I'm going to be using this stab, mock, fake, whatever we call it, just to see if it's producing or giving us some power, right? Let's see if it works. It seems to be working. Very nice breeze. Chilly. I like it, especially that it's so hot outside. Okay, so we have power. What else do we need, right? We need something that would make the sound after the gas is detected. So maybe I can use some like, I don't know, speaker or something. Let's see if this thing works. Does it work? It does. Sorry, it has poor music taste, but it works, right? Okay, and what we also need, we need something to make some lights, like alarm lights, something that can make like a blink blink when the gas is detected. So we're gonna make a use of something like this. See, it does blink blink, right? So we toss it into our box, and then of course we think that more blink blink is obviously better, right? So we're gonna use more blink blink. So we have 2 blink blinks, and what else do we need? Of course, some wiring. You never go wrong with tossing more wires when you build any kind of hardware. So we wire this thing. We then seal this box, and we can say, "Look, Granny, I have built the smoke detector for you. It's very nice. Green smiley faces." It uses tested parts or certified parts. Every part that's in this box has been either certified or tested. It's nice, it's certified, smiling. Now raise your hand if you can install this device we've just collectively assembled, because now you're involved, into your granny's kitchen. And make sure you're not the manager, because sometimes managers raise their hands, right? Apparently, no one wants to install it. Why? Because maybe it's actually a bad thing, right? Maybe it's not so nice. I mean, we've tested everything, but still it has these unhappy faces. So maybe it's time to go for the approach number 2. Maybe we should do something like this. Maybe we should go and buy a proper device that's sold by someone, and they say that this is a proper smoke detector or gas detector and can detect things, right? And disclaimer, I'm not recommending this particular device, right? I just had to use something for the demo. So I'm like not trying to persuade you buy this thing because it's better or something like this, right? It's just for the demo. So I hope you can see that it has this really lovely button here. What does this button say? So what shall we do to test it? Push the button if you... Yes? Oh, shh. Okay. What did we just do? Sorry? We checked the voice, someone said, if I'm hearing that correctly. Okay, yes, exactly. And I can also say we have tested the button. Now, let's do this little thoughts experiment. 3 a.m., and Mr. Gas decided to leak. And do you think the gas is so kind that it would do like, oh, it's 3 a.m. and I'm so poisonous and it's so dark and cold. Maybe I should go to this detector and push the button to wake the lady up. Is this what the gas does? Not really, no. Yeah, exactly. So what do we have to do? We have to do a proper test, right? So to do a proper test, I'll be doing the following. I'm not sure if you should be trying to do this at home. Let me put this thing into a container. I should be able to seal it. Right, something like this maybe. Yes, let's prepare like a little hole in here. Oh, come on, yes. And let's add some extra layer of protection, because you've been to brand stock, right? It's better to play it safe. Okay, yes, and now what I'm going to do is I'm going to use a proper testing gas to see if this thing is really activated by gas. And let's wait. Now it's time for these old dad jokes, right? If you happen to have any, like know any or anything like this. It takes sometimes. Okay, maybe a bit more. We should see some digits being displayed. Bit more gas. Come on.
Attention, please. Carbon monoxide gas leaking. Please open the window and the door. Attention, please. Carbon monoxide gas leaking. Please open the window and
Okay, I guess that's it. We've tested the darn thing, right? Let me turn it off to make it silent. Right, because this is what we do. Like when your build doesn't pass or your test doesn't pass, what you do, you just turn this thing off, right? No, jokes aside, I just need to seal it. So, lovely people, let me ask you this question. What would you install at your granny's kitchen? This thing or this thing? Who votes for this? It's nice, it has the smiley faces. And who would use this thing after unpacking, of course? Exactly. I see many people raising their hands. And please keep in mind that we tested here, or have, and still blinks, yeah? Or have certified every and each part in here. Whereas here, we did like maybe 2 tests with this push the button baby, and then just tested the whole thing. So in theory, this is better tested than this thing. Yet somehow we don't have confidence in this, but in this. And now my question is, if we are so picky when it comes to life and health of the people we love, right? We apply different rules than when we do or make the software that maybe is also like important to some people. Why is the difference? Why do we test or use only like unit tests, right, or part tests only or predominantly instead of going full integration test mode? Why is this? Is something magically switches hats on our heads, or what? Unit test a chip, okay, yeah, very nice. We can get this very nice and cheap test detector. It's been much cheaper to manufacture, right? I didn't have to pay for the testing gas. And it does bling bling, right? Sometimes to test the thing properly, right, the gas detector, and you don't even care what's inside. You just need to test it from the outside. Maybe you can apply it something like people call it like this golden master test, or end-to-end test, or like opaque test. I don't really care about the labels, right? What I really care about is the confidence that after the whole day, or maybe 3 days of conference, when I'm on call, right, or on page duty, and someone calls me to do something, or when we have like scheduled release on Friday evening, even when I'm intoxicated, I can do that with enough confidence. That's the whole point, right? So sometimes to test things, just remember you need some chat, right? That's the whole gig in Polish. So I hope we all know that integration tests are needed. Now let's see how simple they are, at least in the Java world. I'll be using Java as a syntax, but you should be able to use it in quite a few other languages, because what I'll be using today is a library called, a family of libraries called test containers. And yeah, quite conveniently I have this slide. So as you can see, there's a library for Java, Go, .NET, Node.js, Python, Rust, Haskell, and it's missing Ruby, as far as I can tell, because Ruby is also a new kid in the block, like for 2 weeks or something. And if you need anything related to test containers, you go to testcontainers.org, and this is where you start. Right? It should show you a nice page, and in this page you can see like the features, modules, how to get some help, and whatnot. Right? Yes, and test containers does its thing, not by magic, but because it stands on the shoulder of a giant, and the giant is called the giant is called Docker. And this giant can be intimidating, maybe even scary, right? Because it's big, furry, and maybe sometimes in Kubernetes, right? And what test containers does is, without using YAML or shell scripts or pesky config scripts or whatnot, it allows you to operate, start, interconnect with, and then tear down the containers, right? Using Docker API, right? So we have needs for today. Our Granny called us, and she said, of course, these are the needs for the demo only. Don't build professional software using needs, right? That we have to build and test this CO detector, carbon monoxide detector, which does several things. And the first thing is that it starts in less than 4 seconds, right? And please keep in mind that we have to not only to build it, but also test it, right? And to make things a little bit simpler and easier, I have prepared this detector, right? Okay, maybe let's go through like all the needs first. Sorry. So it should start in less than 4 seconds, an arbitrary number, right? Because business logic. It should check for the registered particles every second, at least. And it should raise an alarm when carbon monoxide particles reach 400 particles per million, right? So this is the level where it should start like alarming us, right, about things. So this is it, written in Java, and it's really like a dummy code. It's not the proper code. So this is the alarm level. See, it's like 400 per million. And then we're going to record how many poisonous particles we've detected, and other particles as well, like, oxygen, nitrogen, and whatnot. And we're going to use HTTP server, which is part of Java, if I'm not mistaken, since version 8 or something like this, right? And we start our program. As you can see, it's really simple Java program. And to log stuff, I'm going to use this logfmt format. Who's working in Go? Golang? Okay, so this is like a format that's used in Go, basically, or Go world. So instead of having like a specified list of parameters, you can say like the name of like a property equals, and then there's the value in the log line, right? So I'm using something resembling it. And then I'm going to pass the port that I'm supposed to listen at, and then I create my detector at a given port, then I tell it to start operating, and then I log that it was started, right? And how does the detector look like? It gets the port and then creates the HTTP server, right? And I'm creating a simple context. And then when it receives a post request, it captures the particle. If it gets the GET request, then it prepares us a report. It's not really mandatory or wasn't really required, but let's say it's convenient. And else I'm going to send like an error. And as a response, we're going to send JSON, of course. And how start operating looks like. So I'm going to check or perform this check of registered particles, or the ratio of the registered particles every second. And don't do that at home, please. It's demo only. I'm going to emulate that this thing starts like for 3 seconds at least with this thread slip, right? And then I'm starting the server. And how performing this check looks like, I'm going to log that I'm checking, thing, and then I'm going to get the big decimals of both this and this, and then I'm going to divide carbon monoxide particles by all particles, and then I'm going to compare it against alarm level, and if this level is if we reach the level or go beyond, then, or at least go beyond, then I'm going to raise an alarm by simply printing alarm, right? And this is how I create the report, and this is how I capture the particles. I basically get the body of the payload of the request, and if it's CO in any case, then I say increase the number of CO particles, else it must have been some other particle, right? And then it's like I'm not paid by JetBrains, but maybe they should consider doing so, because apparently they don't teach people the most important shortcut in IntelliJ. And the most important shortcut in IntelliJ, in case you're using Linux or Windows, is, what is it? What? Run program, no. No. It's Control-Shift-T. It opens you, if you happen to have a test covering this piece of code already, it opens you this like a highlight, right? Or also offers you a way to create a new test, right? So I can easily navigate to the test and then Control-Shift-T, and then I'm back again, right? So it's easy and quite convenient to switch back in there, right? So I have a test for you. Also prepared, and these tests have been disabled just to not overwhelm us with all these failures and whatnot. And what I'm going to do here, I'm going to use test containers. How do you start using test containers in the first place? You go to your POM or Gradle build, right? And as you can see, I'm going to be using JUnit, right? And then, oopsies, this is not the latest version. The latest is like, I don't know, 18.1 or 2. Yeah, you add test containers in a test scope, and then I'm also using, or I might be using JUnit integration. This is not mandatory, and also like other containers. I'm not using this, I believe, and this today, right? So yeah, but this is the first and foremost thing you need. All right, and then in your test, you can use, for example, a generic container. Generic container is a cornerstone of test containers, right? There are different kinds of containers. You can have containers, and it should be really nicely seen in, where is it? Test containers. You can go to modules, right? And you can see this a bunch of database modules or other modules, and say, for example, you have like a Kafka dependency, so you go for Kafka containers, right, on this web page. Come on, internet, conference internet, come on, please, please. Okay, and then after adding, for example, this to your Gradle or this to your Maven, right, you can create a Kafka container simply like this, right? You just need to say or tell it what Docker version, what Docker image it should use, and then it will do everything that Kafka needs, like at least in the very minimal setup, like zookeeper, setting environment variables, blah, 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 yada, 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 right? So I would say in case there is like a module already kind of like wrapping technology you're planning to use in your integration test, go for it. Else, like we are going to do today, stick to the generic container, right? And as you can see, I have this test, and this test, what does it do? It says I should be, or the detector should be starting in less than 4 seconds, okay? And how do I do that? I'm going to use this try with resources. This is really old stuff, like Java 7, I believe. And what does it do? It basically makes this container available inside this block. And when this block is left, then the container will be also removed, right? Because it's auto-closable. It implements auto-closable, right? And then I create this container, I start this container, and then I can play with this container. This is like the very basic elemental manual way of doing this. You can also integrate your containers with other frameworks and technologies like JUnit, Spark, by using some annotations in Spring Boot tests, especially since Spring Boot 3.1. And I believe Oleg Shalayev will cover a lot of these during his like advanced talk. I don't know when is it, like tomorrow or on Friday. Yes. So how do I create this container? I am creating this generic container using OpenJDK 20, right? Because I fancy to write my stuff using the supported Java version. And then I'm copying the jar I produce using my Maven package, right? So this thing, right? I copy it into or inside the container and to be visible as this file. And then I say that expose the port 7890. So this port will be exposed from the inside, and every time it will be assigned a different port outside. It's really important because then it makes your stuff really ready against or to work with random ports, right? So you're not stuck to 8080 in production, for example. And then I'm telling it, this detector, because it reads, if you might remember environment property, that it should listen on port 7890, right? And then start this command, enable preview, because I'm using virtual threads, which I'll be covering on Friday. And then jar, and this thing I copied here. So this is how I create my container. So I create my container, then I start my container, and then I can do things with my container, right? Or with the system that's running inside the container. So what I'm doing here, I'm asking the container for the logs, then I'm splitting them into lines, and then I filter the ones that start with start, no pun intended, right? And then I do this parsing of this log FMT format, basically gathering these timestamps. Why do I need these timestamps? Because first I check if I had at least these two events, starting and started, right, logged out, and at least one checking, because I assume at least one blink happens, right, that it's, you know, in this passive detective mode. And then I get the like the deadline, right? So when the starting is emitted, I add 4 seconds, and I expect started to happen within those 4 seconds, right? Because this is the requirement, right? It starts in less than 4 seconds, right? So let me run this test. Okay, it was green, so maybe I shouldn't run it. No, let's be serious. Let's run the test. Okay. Alrighty, and see the other two are disabled right now, so we don't bother, and the test didn't start. And let's pay attention maybe to the log a little bit. So what does test containers do for you? It's also checking the system capabilities, because it should have like minimum version of Docker, like enough disk space and whatnot. So first it checks if the Docker is okay. Yeah, Docker is okay. Basically, checking the system, Docker is okay. Then it's creating container for this image. If I didn't have this image already sort of downloaded or in the Docker's nomenclature pulled, right, it will pull it for me automatically from any public or private repository, as long as it's accessible from this machine or CI machine, right? Because I already have it here, then it starts this container, and then it also starts the container of Ryuk. And Ryuk is basically an image that's run by default, and it serves the purpose of garbage collecting. So in case I forget to stop my test containers manually, it will do the job for me when the whole process or with the whole JVM or JDK process stops, right? Then it will detect, oh, the process that created me is already gone, so I shall basically kill all the other containers started by this process, and at the very end commit seppuku, right? So we can see the image was starting, right, and the container started. Very nice, 1.3 seconds, right? Some people say that these tests are ridiculously slow, not necessarily, as you can see. And we were expecting started there, right, but it wasn't there. We only see, this is the whole log. It says starting, so there's no started, right? How come? Does it start? Doesn't it not start? What's the problem? The problem is that we are not friends. Do you have some friends in Spain? You people should be friends with this lovely Spanish guy whose name is Manuel. Really. Write and read a lot of Manuel. Really. We didn't read the manual of generic container or test containers in general, and there's a thing involved called waiting strategy. So basically, the question is, when or how does the library know when the start is finished? or can release the control to the flow, so to say, right? So normally, when you expose a port, it assumes that when this port is open, I shall continue with the process. There is no longer reason to block start method, right? However, if we go back to this detector, you can see that it opens the port here and start operating, right? Because the server starts, and after that, it prints here started. So the way the library sees this thing inside, it's already started when it listens or something opens this port to be exposed, right? So we have to tell it should wait for the started message. So let's do that. Wait strategy, that was, I guess, oh, sorry, wait, now I forgot what to put it. Waiting for, see, this is what happens when you don't do that every day. Strategy, what should I put here? I know, what can I do here? Hold on, you didn't see this. You didn't see this. You didn't see this. But this is like, you know, a little bit of stress. I should put, yeah, let's basically copy this thing. Copy and paste, right? The best method of creating software. Yes. Right. So yeah, it was just wait, not wait strategy, but wait. Very nice. Right? So now I'm telling the library underneath, right, the test containers, you should be waiting for this log message that starts with started, right? And when you encounter such a line, then it means the container is started, right? So let's start the container again, or let's rerun the test. Very nice, it's running. It passed, right? So apparently our software can start when it's packed into this container. It can start in no longer than 4 seconds. Very nice. Let's go for the other requirement, which is should check at least once per second. So should make this blink at least once per second. And how do we do that? How do we do that? Again, I'm creating the container the same way. I'm starting this container, and then I'm checking the events. Again, see, I'm passing the lines, and then I get the list of all the checking events, right? Because I need to know how many there were, right? And then I'm using a tool called awaitility. And what does it do? You can see this given and until, and this DSL is already telling you something. So basically between 3 and 4 seconds, because let's say I'm going to wait 4 seconds after it started, right? Or something between 3 seconds and 4 seconds, and then I expect at least 3 times blink, 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 apart this blink that was emitted when the whole thing was starting, right? That's why I check this before size versus check events is at least 3 elements, right? So I expect this checking, checking, checking. Okay, so let's run the tests again. And maybe let's run them all, and maybe let's emulate the CI approach, right? Oh, it doesn't seem to be working. It doesn't check at least once per second. It says condition timeout exception, right? Expected the predicate to return true, but it returned false for this input. Ha. And we see only one checking as an input. A bug. How nice. We discovered it before we installed the whole thing in production, right? Okay, so any ideas? What's wrong with this thing? Waiting for message. Okay, but we've waited, like at least, we've waited between 3 and 4 seconds. Right? The message doesn't appear. Okay, let me maybe cut the corner a little bit. But you reviewed the code with me and nobody complained, right? There is this famous Polish saying, sorry, if you're not from Poland, I'll translate later, and it says, pamiętaj cholero. Exactly. Remember not to divide by 0, right? Sorry for my French. Okay, so see what happens here right? What happens in this piece of code when we just start it and we didn't detect any particles at all, right? Then we divide 0 by 0, exactly. So we have to make sure that all equals big decimal 0. Oops, sorry, I removed too much. See, equals big decimal 0. Sorry. Oh, I'm not using this keyboard. Day by day. Not equals 0, right? Because if it equals 0, it doesn't make any sense to run this test and check it, right? Because if it equals 0, then it throws dividing by 0 or whatever exception, and then it crashes these threads, and then it simply doesn't do anything by checking the very first time here, right? So it runs this, throws an exception, kaboom, nothing's working. Okay, so let's rerun the test again. Come on. Should check at least once per second. Oh, it doesn't pass. Any ideas why? Sorry? Yeah. I'm sorry, you have to speak up, I can hear. Maybe, but maybe there's another thing. Maybe we didn't, I forgot to rebuild the whole jar, because we test the jar, right? We test the jar, so I made some changes to the code, so now I have to change the thing that I'm putting into this container, right? That's why in this kind of test, it's not very intuitive if you really do test the artifact that you ship. Sometimes what people do, they build Docker image, right? And they test the Docker image before they publish this image to a certain repository, right? So I'm emulating this approach, and as you can see, build success, right? Very nice. So we had 3 tests, right? Only 1 skipped and 0 failures, which means this test has passed, right? Yes, because it's not disabled anymore. This thing. Okay, so it passed. And this is, by the way, you see, this is how it would work on CI, right? It would do exactly the same. In your build pipeline, you tell it, for example, to check out the code and run this command, right? And it works the same way, as you can see. So we don't need to use IDE to check it. To run the containers or the test containers. Okay, one last test is this thing. It should raise an alarm above 400 ppm, right? Okay, so get starting container, and now what I'm doing here is the following. I'm creating a simple HTTP client, right? And I'm going to call the container and the port that is mapped, right? So the port 7890 is every time when I run it mapped to a different port, so that's why I have to use this get first map port, right? Because it's a random number every time. And I also have to use this container get host. And I can't put localhost here because sometimes the Docker is not local but remote, right? So please make sure don't put localhost here, or localhost as the Germans say. And then, any Germans in the room? Spricht jemand Deutsch hier? Schade. Okay. And so we have this URI that we're going to call, and then I'm creating this O2 request and carbon monoxide request, right? As you can see here and here, this is the payload, and then I'm going to first throw 1,000 oxygen particles, and then just this one single carbon monoxide particle, and then I will await 10 seconds for all these requests to be sent, right? Tops, and then I expect that within 1 second the alarm will be emitted to the logs, right? Okay, so let me run this test, and let's see what happens. Does it pass? Doesn't it pass? What do you think? It doesn't pass, of course. What demo would that be if it passed, right? Come on, it's obvious. Okay. Oops, I have a breakpoint here. I don't know why, or maybe we shall see why. Okay, it didn't pass. It didn't pass, right? Ideas, why it didn't pass? Come on, people, we're running out of time. Shout. Stack trace? Yeah, of course. Let's see the reason. Yeah, that's very good. Condition, timeout exception. So we had this checking, like starting, checking, started, and checking for this 10 seconds. So it was checking, yet didn't raise an alarm. We can say maybe it doesn't, how is it called? Maybe it doesn't register this particle, right? So what I can do, and this is very nice, because when you run your integration tests only in your, come on, hold on. Let me do the following thing. Maybe let's do that without breakpoints, right? When you do the thing with CI, and when you just commit a code or git push, right, to your repo, and then you discover the next day that the test didn't pass, and then all you have is this cryptic log, right? And the beauty of running integration tests on your machine is that you can stop the world, like like in these gangster movies, everybody freeze, and then you can examine the state of your application and containers, right? What's really happening here, and this is what we're going to do. So I'm going to comment this out for a minute, and let's use this reporter that we had before, right? So let's see how many or what particles it actually detected, right? Let me add this to method signature quickly, and let's rerun the test. And let's ask the container itself what particles it detected. Okay, and we can see that it was 1,000 other particles and 1 CO particle. So it's clearly above the level. So why on earth it didn't ring the alarm? Again, let me cut the corner, right? And the whole thing is here. It's how we divide again, right? Because when we divide integers by integers in big decimals, it will round to integers, right? So we need to say here alarm level dot scale. So we have to tell it, I want to be that picky, to be as precise as this alarm level, right? So now let's run the test again, all tests, right? And let's see if this thing goes green. Let's keep your fingers crossed. Okay, this will take a minute, so time for good dad jokes, right? Do you know why we call medieval as Dark Ages? Anyone? There's a very nice medieval castle here. Sorry? No electricity, yes, that's true. Witches, yeah, at least they were burning them, but again, no. It was a medieval thing. They had a lot of knights. Okay, yeah, it's really bad, I know. All the tests have run, there are no failures, and so on. So it's a great success. We've created the system according to the specs, right? Everyone is happy, there is a joy, right? And champagne flowing, and so on, unless you're using Scrum, and your product owner comes, be that your manager, and tells, boys, listen, it's very nice, right? And girls, like, stop cheering up, like, people, calm down. There's a new requirement, right? There's a new requirement because the investor requested that the Java thing is too big, right? They don't have a container big enough because, Java is old and slow and everything. And we have to, make it like a small native executable. So what do you do, right? There's always this Rust guy in the room, right? And they say, shouting, let's rewrite the Rust. What do you do, right? You throw it out of the window, of course. Right? No throwing people, right? Like anywhere. Of course, then you go for GraalVM, right? And you GraalVM your thing. And then what you end up with is this lovely native executable in here. That's quite small. Let's see how small it is. It is just 18 megs, right? And how then you test that the thing is like working properly. And this is like this is unplanned part of the demo. Let's hope it doesn't break. So I need to go to the test. right? And let's do the thing. I'm not now going to copy the jar file. I'm going to copy the this executable file, which are just created using Graal. Let's call it exe, and let's call it like what's it called, detector. Right, okay, so and then I'm not going to use OpenJDK, but I'm just going to use Ubuntu, what was that version, 22.04, sorry, too many twos, 04, and I'm going not to copy jar, but exe, and I'm going to copy it as TMP detector. This should stay, and then I'm not going to call it as Java, but TMP/detector, come on, right, not this. Right? Okay. We have this thing graaled. Let's see if it runs. Let's see if it runs. If it passes the tests. I don't know. I mean, I didn't know that the product owner will come and come with such a ridiculous, last moment requirement that I should like do something else, not deliver a Java file, but native executable, right? Or maybe even like a Docker file. Like a totally new, it might not work. We'll see. Okay, Ubuntu container started. That's already something. Come on. By the way, let me use the time. If you like test containers, right, we'll have like a 3-hour workshop tomorrow, Oleg, Shalaev, and I. And Oleg will also have one like advanced session. And I also have put some stickers there and there so we can approach the stage and grab them. And yes. Does this thing move or not? Because I was talking and I don't know if it's moving. Ooh. Maybe let me try it here. We should be able to check some progress if it's working. I don't know. Maybe it doesn't. It's a demo. Sometimes demos don't work. Should check at least 1 per second. It passed. Should raise the alarm above. It passed. It should start less than 4 seconds. It passed. Very nice. See? And now we have time to rewrite this thing to Rust. Okay? And we can still keep our test written in Java. Because take a look what we already did here, or what we actually did here. We didn't start, like, let's assume your system is using databases or message brokers or caches or whatnot, right? Then you put these like Kafka modules or Redis modules or PostgreSQL modules or MySQL modules or local stack modules or whatever. You bring them up, right? And you tell your system, hey, this is how we contact PostgreSQL, this is how we contact like Redis, and then your system is tested against these real dependencies, right? Not something ephemeral. And instead of bringing them up in YAML or shell scripts, you can start them using Java, C#, Python, whatever you please, right? So I've even heard stories that some companies have this policy that integration tests are not written by developers, by QA teams, and quite, by accident, QAs operate nice in TypeScript or JavaScript. So they write or test, for example, software written in Python, using JavaScript version of test containers. Doable. I don't know if I can recommend it, but doable. I'm not sure if I can recommend it because then you lack this ability to put a breakpoint or change. You see, I didn't put a breakpoint because we already saw that, but I could put a breakpoint like we had before and then, for example, freeze everything and check the state of the system that's running inside the container. I could then go and check the state of the database, for example, if what tuples are there in these tables, and so on and so on. Right? So that's why it's very nice because test containers allows you not to discover how your system behaves against real things in CI or staging, but you can check it on your own machine. Right? You just need to have or provide it with a valid Docker environment, and that's it. That's really it. Okay, so these were the needs. One more thing, if you're also intrigued about like more advanced topics, for example, how to start faster and so on, I do blog posts about test containers on my softwaregarden.dev page, right? And now, important things. Yes, always And for every speaker at every event, community event or conference, provide feedback, because people need to know how it went, what did you like, what you didn't like. I can accept feedback in any form, can be paper, but I guess the best thing would be if you go to this Devoxx app, right, and vote for this talk and any other talk. If you are not able to use this app, or you're watching this on YouTube, then in one of these corners there will be a link to this poll. You can let's say here, you can go or here, you can go and fill this poll, right? It's anonymous, and make sure you subscribe, like hit the subscribe button. Yes, this is it. This is the talk. There are links with the code and slides. Dziękuję bardzo. If you fancy, you can follow me on social media for Java insights, I don't know, some IT hints or general like pool life advices. So this is also what I do. Yes, and this is the slides for you. Enjoy the stickers, wash your limbs, and stay safe. Thank you very much.